Okay, today we're taking on an entrance exam from MIT, the Massachusetts Institute of Technology, from 1869. This exam is really, really old, so that's why I thought it'd be fun to do it, thought it'd be interesting. This is the algebra portion of the exam. There looks like there was an English portion to the exam, a geometry portion, an algebra portion, and an arithmetic portion. So a few of these questions are Algebra One questions, and a few of them are Algebra Two questions. So the Algebra One questions will be easy. The ones that I think that you can complete on your own are numbers 1, 2, and 7. Because number 1, all you have to do is plug in 8 and simplify down. Number 2, you just have to do some distributive property and simplify down. And then number 7, this is a system, so you can kind of stack these two equations on top of each other, and I would solve by elimination. The rest of them are more Algebra 2 concepts. So we're going to go over all of the questions to the exam rather quickly. We're not going to go through it slowly because they are very time consuming. But I just kind of want to give you an idea of where the answers come from. So for the first one, I plugged in 8 everywhere where E is. So I plugged in 8 here, I plugged in 8 here, 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 here. Okay, so that's how we got to the second step. Then I started simplifying down. So 8 plus 1 is 9. 8 minus the cubed root of 8. Well, the cubed root of 8 is 2. So 8 minus 2 is 6. 8 minus 4 is 4, and the square root of 4 is 2. Then what I did is I said, okay, well, the square root of 9 is 3. 3 plus 2 is 5. So now I have 8 minus 5, and then plus, this is 12. So 8 minus 5, that's 3, plus 12 is 15. For this next one, I used the distributive property here. So I distributed the negative to A and the negative to negative B, and that's how I got negative A plus B. Then what I did was I started to distribute the negative, let's see what I did. Okay, next what I did was I said, okay, B cancels out with negative B, and I'm going to be left with 2A minus A plus B. Well, 2A minus A is A, and then plus B is what I'm left with, but I still have the negative in front here, so I need to distribute that negative through. So 3A minus A minus B. 3A minus A is 2A, and then we have a minus B. For this next one, this problem said multiply 3A squared plus AB minus B squared by A squared minus 2AB minus B squared and divide the product by A plus B. So what I did was I just wrote it out like this, multiplying the two terms on the top, dividing by A plus B. I looked at this expression and I thought, okay, I could factor this. I could factor this to A minus 3B and A plus B, because what multiplies to negative 3 and adds to negative 2 is negative 3 and 1. There's technically a 1 in front of here. And then you need to put the b's on the end. A plus b cancels out with A plus b. So this is what you're left with. Then I just distributed. So I distributed 3a squared times a is 3a cubed. 3a squared times negative 3b is negative 9a squared b. Went to the next term, distributed, and then distributed the last term, and that's what made this expression. Then I combine like terms, so negative 9a squared plus b plus a squared b is negative 8a squared b, and then I combine like terms over here as well, simplify down, and this is what I got. Next, this is a fraction that we have to reduce, so I looked at this and I thought, okay, well, I can definitely take out an x cubed here. I could factor out an x cubed because that's what they have in common, so factoring out an x cubed, I'm left with x cubed plus a squared y. And then at the bottom, I said, oh, well, this is actually 2 squares here. This I can factor into the difference of 2 squares, so that would be a plus b, a minus b. So this factors to x cubed plus a squared y, x cubed minus a squared y. And then the x cubed plus a squared y and the x cubed plus a squared y canceled out, and this is what I'm left with. This next one is tricky. You haven't done anything like this before. This is definitely more of an Algebra 2 concept. So for this one, we're dividing. What I did was I made a common denominator here. So my common denominator here is a plus b, a minus b. And the reason why that is if you thought about having let's say fractions with the denominator 3 and 4. Well, the common denominator would be 12, right? So all you did was multiply 3 times 4, and that's 12. So I'm going to multiply a minus b and a plus b, and that's a minus b, a plus b. So if I multiply this part, this term, by a minus b, a plus b, the a minus b's will cancel out, right? Imagine if I had like an a minus b up here and an a plus b. The a minus b's will cancel out, but there's still going to be an a plus b, and that's going to get multiplied by this a plus b, so you have a plus b squared. Then I did the same thing on the other side. On this side, you're missing an a minus b in the denominator, so when you multiply it, it now turns to a minus b squared on the top. And I did the same thing over here as well. Since we're dividing, I decided to keep, change, flip. So keep the first term, multiply, and then flip, right? That's our rule, keep, change, flip. So the a minus b and a plus b cancel out here, and you're left with a plus b squared plus a minus b squared over a plus b squared minus a minus b squared. So you look at this and you might think you're done, like I don't know if I could really simplify anything else. You might want to try to cancel this part out, but you can't because of the plus and minus sign here. So what you need to do is you need to expand everything out. So a plus b squared, that's a plus b times a plus b, and when you FOIL that out, it becomes a squared plus 2ab plus b squared. So that's where that comes from. Do the same thing with a minus b, expand out, and that's this part, which is right here. Do the same thing on the bottom. Then what you're going to do is you're just going to combine like terms. So 2ab minus 2ab, those cancel out. A squared plus a squared is 2a squared, and then plus 2b squared. And then combine like terms on the bottom as well. And then the last thing I did was I factored out a 2. Well, I reduced it really to 1/2. So take out a 2, take out a 2, take out a 2, and that's really what you're left with. Okay, number 6. This you haven't learned, but this one's easier. So for this, I had to make a common denominator, and obviously my common denominator is going to be 16, because I have a 2, an 8, and a 16. So if I want the common denominator to be 16 here, I had to multiply by 8. So I'm going to multiply my numerator by 8. That's why I have an 8 here. For this one, I need to multiply by my numerator by 2. And for this one, this fraction stays the same. Then what you're going to do is you're just going to distribute that 8 through. You'll distribute the 2 through. And that's how I got to here. Then what I did was I put this all in one fraction. I combine like terms. And then once you have the same denominator here, so since you have the same denominator here, it's just going to end up canceling out. So you could really just set the numerators equal to each other. 12x minus 22, and then 3x minus 1. I solve my equation, and I'm left with x equals 7/3 when you reduce. The last one is a really simple question. It's a system. Looks like this. Solve 7x minus 5y equals 24, 4x minus 3y equals 11. I just stack them on top of each other, and then I solve by elimination. I decided to cancel out the y's, so I multiplied this equation by -3 and this equation by 5. I distributed through on the top and the bottom, and that got me to these two equations. Positive 15y cancels out with negative 15y. And then when you add down, you're left with negative x equals negative 17. Divide by -1, you're left with x equals 17. Then I plugged back in to this equation, but you can plug back into either one, remember that. And I got my y, and that was 19. So the coordinate point is 17, 19. That's where those two lines intersect. And that is it. That is an entrance exam from 1869 for MIT. So I hope you thought it was interesting. Let me know what you think. Have a good day.